Dr. Manjunath Chennapagowd from Anveshana Academy, Bangalore, India. Dear students, in the previous video we discussed about gas power cycle. Why the gas power cycles are required and what are the importance of gas power cycles. This all we have discussed in the previous video in detail. So today we will move towards next topic. Gas power cycles. Dear students, what is gas power cycle? What are these gas power cycles? So gas power cycles are thermodynamic cycles where a gas is used as a working fluid to convert heat into mechanical work. I repeat, gas power cycles are thermodynamic cycles where a gas is used as the working fluid to convert heat into mechanical work. So what it means then, that you can see here, dear students, that means these are the, so what these gas power cycles, gas power cycles, what they are doing, they are going to convert heat into mechanical energy with the help of gas as a working media. So assume that I want to convert heat into mechanical energy. So as I told, heat energy, you can call heat energy into mechanical energy. So directly, as I told, law of conservation, what it tells now, because sometimes we may require different kind of energy. Sometimes you can see your lighting, or if you want to switch on the TV or fridge or some either, if you want to run the machines, you require electrical energy. Then what you can do, heat energy can be converted into electrical energy. So that can be done with the help of machines. Those are nothing but what? Gas turbines, we can say. So similarly here, heat energy can be converted into mechanical energy. Directly we can't convert. To convert that heat into mechanical energy, we require one medium. That medium we can call it as a gas. So here the gas act as a working media. So what we can say, the heat energy can be converted into mechanical energy using gas as a working media. Such cycles we can call it as a gas power cycles. So the gas power cycles are thermodynamic cycles where heat energy is converted into mechanical energy with the help of gas as a working media. That is known to be gas power cycles, we can say. So these gas power cycles are fundamental to the operation of many devices we rely on. That too, from car engines to jet engines. You can take, dear students, car engine to jet engines. All these depends on the fundamental operation of the gas power cycles. Without gas power cycles, we can't design car engines or turbines or jet turbines, what we are using nowadays. Fine. So this development of this cycle has been a journey of innovation driven by the need for more efficient and powerful machines. So the development of this cycle, later we based upon these gas power cycles, later we designed and we developed some powerful machines. With the help of that powerful machines, we can get mechanical energy directly. How it is, that you can see here now, dear students. Fine. So to convert heat energy into mechanical energy, we required gas as a working media. Fine. To convert this heat into mechanical energy, we required one machine. Hence, the scientists or inventors or engineers, they started to search for an efficient machines which converts heat energy into mechanical energy. So to convert heat energy into mechanical energy, they came to know that there is a requirement of some gas power cycles. Hence, they started to develop some gas power cycles. What are the gas power cycles? That I will discuss in detail in upcoming classes. Okay, so the scientists or engineers or inventors, what they've done, they started to develop the gas power cycles. Then they developed gas power cycles, they started to use in the car engines as well as the jet engines. Based upon the developed gas power cycles, we designed car and jet engines. Okay, fine. Now, how these gas power cycles work actually? So, the simple working principle of gas power cycle you can see here, dear students. Here, we are using working fluid as a gas. Okay, then gas will enter into the machine. You can say, dear students, you can take an example. This is a machine. You can take a machine. You are supplying gas. Okay, so introducing gas into the machine. Okay, fine. That is the first thing. Then to increase the temperature or pressure of that gas, we need to supply heat. Why to supply heat and why to supply heat? Because to increase the temperature and pressure of the gas. Why to increase the temperature and pressure of the gas? Because to get the explosive forces. Because of that explosive forces, what happens? There will be expansion. What is that expansion? When we are going to supply heat to the working fluid, that is gas, it is going to increase the temperature and pressure. Because of this increase in temperature and pressure, what happens? You can take in a machine, the expansion will takes place. So fluid expansion will takes place. That expansion will help us to perform the work actually. How it is? Simple thing you can take, dear students. Assume that I will take an engine now. Okay, I will take an engine. In this engine, first what I will do, I will fill this engine with a gas actually. Okay, filled with the gas. Then what I will do, I will try to supply heat at the bottom. Okay, assume that it's already compressed gas is there. What I will do, I will supply heat energy to this. So initially introduction of the gas, then what, it is already compressed. Then what I will do, second thing, I am going to supply the heat to the gas. Then what happens now? When we are going to supply heat to the gas, what happens now? So sorry, this is piston is, assume that, sorry, I will take this 1 minute. Now I will take piston in this arrangement. Okay, piston in this arrangement, piston and cylinder arrangement in this fashion. So I will take gas into it. I will take gas into it here. Now what type of gas I have taken? As I told, assume that compressed gas I have taken. Compressed gas I have taken. So now assume that this is a piston and cylinder arrangement. So what I will do, initially what I have taken a gas that is in compressed. Then what I will do, second case, I am going to supply heat to the gas actually. Once we are going to supply heat to the gas, what happens? The pressure and temperature of the gas is going to increase. Because of pressure and increase in the temperature and pressure of the gas, what happens now? The gas will start to expand. That means what? It is going to create explosive force over the surface of a piston. Hence the piston will start to move upward because of expansion of the gas. One thing. So once the work is done, what we are going to do? We are going to reject the heat from system to the surrounding. The next, what we are doing, again we are going to fill the gas into the cylinder and we are going to compress it for the next cycle. This is how the gas power cycle works. Now, these gas power cycles are invented overnight? No. It took years together to develop such kind of gas power cycles what we are seeing today. A lot of scientists, many scientists, they have sacrificed their life towards the development of science and technology. Hence, dear students, we should be very grateful to such a scientists or engineers or inventors who have sacrificed their life towards the development of science and technology. Here are some scientists we can recall. Okay, so now this gas power cycles are not invented in a night, are not invented in a year, are not invented in a month or week or something else, but it took years to invent the machines. So initially the gas power cycles is started in the year of 1690 by a scientist. That scientist name is Huygens. What is Christian Huygens? What he has done? He designed an early internal combustion engine using a gunpowder. So, dear students, he has designed an engine. Then he started to use a gunpowder to run the engine in the year 1680. It's a starting era. He started to run the engine with the help of a gunpowder. So that engine popularly we call it as a Huygens engine. Huygens engine means it is an engine which is worked on the gunpowder. This is what first history, you can see Huygens engine. In the second, after 1680, see, you can see in the 1791, one more scientist, that is John Barber, has patented on the gas turbine design. Later, in the year 1791, one more scientist came. That scientist name is John Barber. What he has done? He done a lot of research on the gas turbine design and he has patented. Then that engine we are using nowadays. Okay, after this 1791 at 1861, one more scientist, that is Nicholas Otto, developed a four stroke petrol engine, and he made a patent. Okay, so later Nicholas Otto developed the four stroke engine which is operating with gasoline or petrol engine, and he made a patent. Latest stage, he has invented the four stroke petrol engine in the year 1862. Later to this Otto, one more scientist, that is Rudolf Diesel, in the year 1890, he patented on the diesel engine. So what he has done, Rudolf Diesel, you can see here, Rudolf Diesel, what he has done, he invented the diesel engine, the engine which is operating on a diesel, and he calculated the efficiency of the engine with the help of his own way or concept. Then that engine we call it as a diesel engine. Okay, fine. Later in the year 1930, you can see Frank Whittle and von Oyen developed the turbojet engine. That is the revolution thing in the aviation. In the 1930, the first Frank Whittle and von Oyen developed the turbojet engine, and it's become a revolution in the aviation. So in the 16th, you can see in the 6th stage, in the mid 20th century turbines, many gas turbines are found. Gas turbines are started to used in the different sectors like power generation sectors, industrial process, and marine propulsions. So later in the mid 20th century, we started to use the turbines which are developed by the Barber turbines in the real applications. Okay, after this 20th century, many scientists, they started to work on the engines to improve their efficiency and reduction in their emissions, as well as they have started to work on the alternative fuels to run the engines. This becomes modern research. Okay, this is how the history started of the gas power cycles. From Huygens engine to modern research, there is a history. So what is a gas power cycle? Gas power cycles are thermodynamic cycles where a gas is used as the working fluid to convert heat into mechanical work. Now here we can see what is this gas power cycles. We will try to understand background of gas power cycles in simple terms. Gas power cycles, principal application in the different area that we will see here. Now what is gas power cycles, we understood now. Okay, how it works actually, what is the basic principle of this gas power cycles? It is uses gas as a working media. To get the expansion from that gas, we require heat addition. Because of that heat addition, we are going to get the expansion. Once the work is done, heat has to be removed from the gas, hence there will be a heat rejection. Then to get the work done in the next cycle, the gas has to be compressed with the help of a compression process. So these all are the basic principle of a gas power cycles. Then this performance of this gas power cycles having some key parameters. So key performance parameters of the gas power cycles, what are those? First one is thermal efficiency, power output, and specific fuel consumption. Like that many will come, but important performance parameters are thermal efficiency, power output, specific fuel consumptions. This with the help of this gas power cycles we can determine these three. Okay, and these performance parameters are affected by some factors. I repeat, these performance parameters are affected by some factors. What are those? Compression ratio, turbine inlet temperature, and friction losses. When it comes to engine, dear students, we can take the compression ratio. We can call, in short, we can call it as a CR. Compression ratio also play a very important role in the engines. We can take a diesel and petrol engines. We know already diesel engine having more compression ratio, hence they are having more thermal efficiency and more power, whereas petrol engines having lower compression ratio, hence they are producing low power and lower thermal efficiency when compared to diesel engine. Hence compression ratio play a very important role on the performance of the engine. If the compression ratio is more, we can get more power output, less fuel consumption, and the efficiency of the engine is good or higher than the lower compression ratio. One thing, and friction and other losses, that also affect on the engine. When there is a piston and cylinder arrangement, right, there you can see here now in the engine, if the friction is more, then it is going to consume more power, hence there will be a loss in the power. That loss in the power we can call it as a friction power or friction. The power loss due to friction, that we can call friction power. So hence, like that also affect on the efficiency. If the friction is more, the power output will be less and fuel consumption will be more, the efficiency of the engine is less, hence the friction should be less. That's also affect. Fine. Now this gas, what are the important gas power cycles are there? So there are some common gas power cycles are there, namely Otto cycle, diesel cycle, Brayton cycle, and dual cycle. Where we are using this kind of cycles, where we are using this kind of gas power cycles, you can see now the application of the gas power cycles are in internal combustion engines, gas turbines, and jet propulsion. When it comes to internal combustion engines, generally we are using Otto cycle and diesel cycles. Otto cycles are used to design the petrol engine, whereas diesel cycles are used to design the diesel engine, whereas Brayton cycle, dual cycle, Rankine cycles are used to design gas turbines as well as jet propulsion. Okay, this is about applications. Now, so as I told here, one more thing I want to tell, turbine inlet temperature. When it comes to power generation system, right, we can take a gas turbine. At what temperature the gas is getting inlet, that means what enthalpy we can say, internal energy content in the gas during entry, that's affect on the performance of the performance of the turbine. If the temperature or if the heat content of the gas is more during entry, then we can get more electrical energy. So that's also very important rule. Whenever the gas is coming out, right, it is going to have an enthalpy at the exit side, it is H2. Generally we know after work done, H2 is going to decrease than the H1, low temperature compared to H1. So when gas is entering, it is going to have high temperature as well as high enthalpy. When it is coming out, it is going to have a low temperature, we can say T2, and we can say H2, where T2 and H2 are lesser than the H1. That's also, these two important parameters also, they are going to affect on the performance of the gas power cycles. If it is good, if it is small, then we can get the more power from the electrical generator. Okay, so once again, what are the important gas power cycles are there? First one, Otto cycle, diesel cycle, dual cycle, and Brayton cycle, dear student. Okay, so what is this Otto cycle, diesel cycle, and Brayton cycle and dual cycle? In detail we will study in upcoming classes. Dear students, I hope you are understanding my classes and uh, you are getting the things. Here I request you, it's my humble request you to please subscribe my channel, like and do comment, and share the videos to your friends also. So therefore you can help others to get the more knowledge on the applied thermodynamics. So please subscribe and do comment. Thank you.